Well, thanks very much, Pam. Boy, those are some inspiring projects. You completely distracted me. So buildings are responsible for about 40% of GHGs globally. 70 to 80% of the buildings that need to be net zero or zero carbon by 2050 are already built. So it's simple. There's just no path to a stable climate without industrial scale deep energy retrofits to existing buildings. In Canada, we have 14 million dwellings. 8 million of those are single family houses. And, it's time to really get going. And we, by a tally of Alex Ferguson at Enercan, we have 6,800 archetypes of houses, all the way from the 1920s to code built buildings that are still being built today, from simple bungalows to some of the sort of Victorian knockoffs with all kinds of dormers and roof forms and that we were building in the 90s. Some of them have old windows and siding and roofing that need to be replaced. Others are in perfect shape and really don't need much. We've got energy hogs and we've got pretty efficient houses, and climate zones from the Okanagan to Grand Prairie and north, and all kinds of different details on these buildings and situations, anomalies, changes that are made that are going to take a variety of procedures. And on top of that, we've got different approaches to retrofits. We're interested in deep retrofits that get to zero carbon, as opposed to piecemeal retrofits, which I'll talk about in a second. And in the deep energy retrofit, you can either do it in one shot, which is the most economical, or plan it over stages. Some will involve envelope only, some envelope and mechanical, some mechanical only, as you might in the Lower Mainland in BC, where you can throw in a heat pump, use renewable energy and some weather stripping, and you call it good. And then of the big envelope upgrades, we've got site built and panelized. And panelized is what we're going to focus on here. But just I want to sort of a word of caution about incremental retrofits. So these are the kinds of things that we've been doing for about 50 years in Canada, where we fix one little thing on a building and don't look at the whole building as a system. These kinds of improvements will never get us to net zero. They will reduce the energy use of that building and save some GHGs, but they tend to lock in the remaining emissions and make it even harder to get that building to zero emissions in the future. Good example is one of the Sundance buildings. I'll talk about in a minute. The siding was gone essentially, or needed replacing. They replaced the siding and added only ½ an inch of insulation, didn't do anything about airtightness. And now we've actually just covered up that siding in a proper retrofit, and we would have loved to have had that money. And this happens with attic insulations, where you add insulation in the attic without improving the airtightness. Which is an even bigger heat loss than the transmission loss, and replacing windows with mediocre windows that need to be replaced to really get to zero carbon. So we get one chance on most of these things, and we've got to start to use that to do a full-scale deep energy retrofit. And so, very thankfully, with help from SSRIA, we're doing a 3-house project with that will use a panelized approach to get these buildings to net zero. And we're using the energy sprung approach. This was developed in Holland over the last 5 or 6 years. They've got hundreds of thousands of post-war townhouses with virtually no insulation. And they're using an approach where they use a laser scanner to capture the geometry of the building, take that back to the office, design a panel system that's built in a factory and comes out and gets zipped onto the building, turning it into a net zero energy building in a matter of a couple of months. So we're inspired by that. We're applying that a sort of a Canadian version of that to a 59-unit 1970s townhouse complex here in Edmonton. As far as we know, it's the first attempt to apply energy sprung other than a fourplex in Ottawa, anywhere in North America. And so far it's going reasonably well, not as fast as we want. We're on our 7th out of 15 buildings, and getting a little bit faster each time. And so the advantages of a panelized retrofit, the Sundance approach essentially is similar to the energy sprung approach. We're making panels off-site that we install on the building on a support system that we've developed, and then fill the cavity with cellulose insulation, very low carbon insulation, and then putting a scissor truss roof over the existing roof and wrapping it up. So the advantages of a panelized system are that the occupants can stay put. It reduces the time on site. There's very little demolition. It's an opportunity to provide a continuous air barrier that it has a huge energy upside. You can dial in the R value to the most economical solution for that particular building. It's an opportunity to make the building way more durable by using a rain screen and durable materials. One of the challenges is that you need to start with an accurate digital capture, which I'll get to in a second. But just our success so far at Sundance has been really gratifying. We're taking these buildings from 3.5 air changes an hour to about 0.6. So we expect providing the co-op with very low maintenance costs going forward. So at Sundance, we're using we had a laser scan done of the entire co-op, and the surveyor sends us a 6 or so gigabyte file that we bring into SketchUp using a program called Undet, and capture the geometry from there and locate the windows on it. And like it's precise enough. So far our panels have all fit very well, but it's a nerve-wracking process. The point cloud, the software extracts exactly what's there. That means the buildings are not square, they're not level, they're not plumb, and neither are the drawings. And we have to sort of judiciously fudge those to make them workable for our panel drawing production. And in the SSRIA houses, we're using a different approach. Logan Gilmore, a brilliant grad student in computing science who comes from the gaming world, saw what we were doing and thought that there was a simpler way. And so he's developed a system where he uses drone-based photos. He'll fly the drone around the existing house or building, and get 20, 30, 40 photos, and then pick the ones that give them the best angles so that to sort of resolve the drawing. And he locates the points of interest on the photo, the tops of the walls, the outlines of the windows, the corners of the building, and does that in multiple photos, and then through some kind of mathematical magic, tells the program that the line in one photo is the same as the line in the other, and to kind of reconfigure it to make it so, and constrains it to be orthogonal. He then, once he's done that with all of the photos, he then takes total station measurements of 3 points on each of 2 walls, and uses those points to and tells the software to make it so that the distance from those measured points is the same in the extracted model. And you can go around to the far side of the building where no measurements have been taken and get measurements that are within 3 to 5 millimeters, which is plenty for our panel production. So it's really it's working well. He sends us a line drawing of the geometry, a 3D file, which we then bring into SketchUp. We fill it in to model the whole house, and then design the panel support system and the panels to fit those windows and door locations and panel constraints. And also we're able to use it to do a certain amount of prefab on the roof geometry as well. And so and then those turn into production drawings for our panel partners in Killam, Alberta, who are prefabbing our panels. So it's actually working quite well on the SSRIA projects. We're at the stage we're just going into construction, but anticipate being done by the end of September on all 3 houses. It's so it's a in addition to the walls are only a small part of a well-designed retrofit envelope. We're also working on different roof solutions, and the solutions are tailored to what's there already. We can't, in order to optimize the costs, we need to do as little as possible to these buildings. And so in the simplest roof solution is being able to air seal the existing attic and add enough insulation inside that roof to get into sort of net zero territory. And we're able to do that on one of these houses. We have enough room to do it. But, and to the point of piecemeal retrofits, we're having to suck out R50 of existing insulation to be able to get it airtight, and then we'll have to put it back in. And unfortunately, it can't be reused. So the second approach is where we don't have enough room in the existing structure. We have to maintain. We've only got a 2x4 thickness, so we're ending up having to build a whole new roof frame over top and then insulate that, which involves a fair amount of on-site work and expense. And the third solution, which we're also using at Sundance and one of the SSRIA houses, is to simply cut off the existing overhang, wrap it with a vapor barrier, put on a scissor truss roof that doesn't add any load to the existing roof, and a bunch more insulation. And that's kind of what it looks like at the Sundance project. So because we're making these buildings airtight, they need HRVs. HRVs have their own benefits as well. Besides giving you a virtually energy-free continuous supply of healthy fresh air, they help you control the humidity and just generally improve the air quality in the building. So they're that's another learning, is how do you retrofit these things without too much drywall repair on the inside. We're finding nifty ways to sort of sneak the ventilation systems in, and because we're retrofitting these to a net zero level, we can safely electrify them. So we're replacing the fossil fuel burning appliances with air source heat pump heating systems and water heaters, so that in most cases, putting enough solar on the roof to make them fully net zero. And one of the upsides and parts of the value proposition is that these houses are getting a completely new look. Like the resale value will be substantially higher, and just the owner satisfaction is to sort of take a dated old house and give it a modern new look. It's an opportunity to do everything at once. So, given the scale of the project, like, what do we need to roll this out, to speed it up? We need, ultimately, in spite of the sort of advances that we're making, these are big renovation projects, and they're going to need a huge workforce. We need energy modelers who can optimize the envelope solutions. We need retrofit coaches. We need a host of retrofit contractors who understand and practice air tightness and thermal bridge-free construction, and a virtual army of skilled tradespeople. So there's a huge opportunity for all kinds of really worthwhile employment. But we also need a roadmap. The problem is so complex. I think we need a set of solutions and recipes that are flexible enough to deal with this diversity of housing, with solutions that are appropriate to individual houses, and we need practice. We're finding with the Sundance Project, by doing it over and over, that we're getting better. We're finding better ways, and we need to throw this out to a community of builders who will help each other build this multi-billion-dollar retrofit industry in really short time. And with that in mind, we're as part of the SSRIA project and EcoTrust as well, we're developing a retrofit roadmap that will be based on a case study gallery and a library of details, and a sort of a flow chart of how to go about this to get the lowest cost, best retrofit for your particular building. And it will work something like this. So we're just starting to populate this gallery, but the idea would be that, if you have a 1950s semi-bungalow in North Glenora and you're interested in fixing your house, you would go to the site and you would find a house similar, say a house in Saskatoon, same climate zone, and there's one and you would see the before and after, the specifications, the photos of the finished building that looks great, what it costs, before and after total cost of ownership, and also links to the details. So that, and by looking at the total cost of ownership, you could see that while it might be more than you're interested in, wanted to spend, that you could afford it, that the increase in resale value, the next to nothing energy costs, which are going up one way or another, and the avoided and future maintenance and the caught up existing maintenance, that that all the numbers in the total cost of ownership could work. And so from that stage, you would connect with a retrofit team that would start to really dial in your project. And you would we're developing a sort of a flow chart that starts with an energy model and a building condition assessment and initial cost estimates, carbon tally, to sort of dial it in and make reference to the best details and drawings and techniques, fine tune the total cost of ownership, and link you to the incentives that are probably the missing piece of the puzzle to be able to grow the industry. And so it all sounds really daunting and scary, but I'm heartened by the path that we went through in developing our approach to new net zero energy houses and buildings. We started in 2006. And, our first one was a science project. We had all kinds of wonderful ideas, and we tried to incorporate them all. And it was it turned out it wasn't replicable. But by the time we had done 4 of them, we had a recipe that we could do in our sleep. And I'm hoping that we can, that getting down, rolling up our sleeves and doing it, we can follow a similar development trajectory that makes this routine and relatively easy to do. It's complex, but the solutions are certainly not infinite, and we can organize. I think we can do it. So thank you very much. And I'm not sure, did you want